All right. Well, thanks everybody for taking time out of your busy days to come to our webinar here, and also reiterate what Liz said about thanking you for answering those questions too, because they do help me gauge kind of where the audience is coming from for the webinar. And it looked like the polls came back about where I would expect for people with the subjects and kind of the depth we're going to go today. So today we're going to talk about choosing the right Azure SQL for your data. So really what variant of SQL we should be using within Azure when we're looking to migrate or start new projects there is what we're going to talk about today. So we're going to touch on 4 different Azure offerings within SQL, or I'm sorry, 4 different SQL offerings within Azure today. As you might guess, that's a lot of different platforms to touch on. So some of the demos are going to be pretty brief. I just want to get in there and let you see it and taste it and feel it a little bit, not just be strictly slides, but we're going to move at pretty rapid pace through the demo pieces at least. So my name is Brad Gall. I'm a senior principal consultant with Pragmatic Works. There's my contact information on the screen. If anybody has feedback or questions after the webinar, feel free to reach out. I'll also put this up at the end whenever we open it up for questions. And a little bit more about myself. I've worked with the Microsoft Data Platform for about 15 years now. I speak at user groups and webinars whenever I can. I reside in Jacksonville, Florida, sunny Jacksonville, Florida compared to the rest of the country lately. And today, though, I'm actually coming to you live from one of my favorite clients in Atlanta, Georgia. So I have a room of folks actually here with me, changing things up a little bit. And then on the side, I'm a part-time basketball / t-ball coach for 5- and 6-year-olds. So another way to phrase that would be squirrel or cat herder. If anybody has volunteered in that capacity, can understand. So let's jump into our agenda for today. So it's a pretty simple agenda. We're just going to review what options you have to run SQL in Azure, and then review the considerations for choosing which of those platforms you should use, and then mix in some demos in there. So a fairly straightforward agenda. Hopefully you come away with it with a good understanding of what the different platforms offer you. And to start things off with that, we should probably explain what are the options for SQL in Azure. So as we stand today, we actually have 4 different options to run SQL in Azure. Probably the most used right now still is an IaaS offering. So just simply running a VM with SQL Server running on it in Azure. So that is one option we have. We also have different platform as a service offerings. So I'll dig into these deeper, but I wanted to introduce them first before I started digging into individual ones. So we have something called Azure SQL Managed Instance. This actually just went into public preview last week or the week before. So it is brand spanking new. I'm just going to touch on it a little bit today, just for sake of time and just for not having time to kind of add demos or get it added to my subscription, etc. But definitely wanted to make you aware that it is out in public preview, hopefully coming to GA at some point, and offers a lot of a whole new different way to run SQL in Azure. And then the final 2 platform as a service offerings we have would be Azure SQL DB and Azure SQL Data Warehouse. So these would be database level platform as a service offerings we have for SQL Server that both run very differently from each other, and we'll explain and dig into how those 2 things are different today. So which one of these options is right for your data? So when I think about this, really for me, it boils down to 2 questions that we need to answer to start things off with. And these 2 questions have a lot of nuances. There's obviously, it's not quite this simple or we wouldn't have an hour webinar on it, but this is really a good starting point for you to decide which of the different paths you should choose for which SQL you should be using within Azure. And those 2 questions would be, should I use IaaS or should I use Paas? So should I use infrastructure as a service or should I use a platform as a service, and why? And then from there, what type of workload are you running? So are we running an analytics workload? Are we running a database that backs up a web application? What type of data are we running? How large is it? How many users are connecting to it? Those type of things. But you can kind of sum it up into analytics or application workload. So we're going to start with that first question, IaaS versus Paas. How do you determine that? Well, I guess first you need to understand what really the differences are between IaaS and Paas. The diagram on the right there is one I've used in the past talking about SQL and actually comparing it to the on-prem version of SQL. and kind of the advantages of and kind of where the evolution of SQL Server and really the IT industry has gone. What we're talking about today, though, is specifically those two blue boxes up in the top right. So those would be, the blue would be when we're into Azure. We have infrastructure as a service and platform as a service there. Now, some of the pros and cons of IaaS versus PaaS, we'll start with IaaS. IaaS really gives you the most control over your environment. So with IaaS, you're running a VM, you have control over your OS, you have control over your instance, and you have control over your databases. So you can install software on the operating system if you need to. You get to control the logical disks within the Windows server if you'd like to. You have full control over that whole OS. The nice thing about doing it in Azure versus on-prem, you don't have to deal with SANs or hardware or anything like that, but you still have control over the OS and everything that comes that you can do within that capacity. Now, the con with that, the kind of the yin and yang of that is with more power comes more responsibility. So we have more maintenance time compared to a PaaS offering with IaaS. So because we have an OS, we have to maintain that OS, and we have to control security to that OS, who's allowed to log into it. We have to install SQL Server, maintain SQL Server installation and patching on that server. So that's something to keep in mind with that setup. It can be a lower server cost. So I put an asterisk next to this and also the one on the PaaS, because if you strictly compare running a SQL VM to running maybe the exact same amount of data on a SQL DB, Azure SQL DB, you'll probably come out with a higher cost on the Azure SQL DB. Now, what that is not taking into account, though, is the total cost of ownership. So that's something to always keep in mind when we're talking cloud platforms. There's a couple of ways to save money. One, we're not going to get into today, but Paas and scale and elasticity can save you a lot of money. We don't have to run our servers 24/7 typically, and we can save some money that way when we migrate to the cloud. But also, how many maintenance tasks are we taking off of our plate that we no longer have to worry about every day, or at least that we are accelerating and doing much faster. So it can be cheaper to start with to run IaaS. And then finally, a pro for IaaS, again, running a SQL VM would be that we have full feature parity with the on-prem. So everything that we have within a SQL Server instance on an on-prem installation, on a server installation, we have everything available to us with SQL on a VM in Azure. Now let's compare that with a PaaS offering. I put serverless there in parentheses. It's kind of the new buzzword, word I hear coming up more and more, especially if you're from the app dev side with Azure Functions. It's kind of the trend is to try and get rid of servers and maintaining servers. But what we get with PaaS is ease of use and fast spin up times, fast spin down times. It's pretty amazing to me coming from SQL 2000 days. We can spin up a SQL database from nothing in 3 minutes. So ease of use, fast spin up time, and it also leads to less maintenance time. So there are built-in backups on every Azure SQL database that we spin up, depending on the level of service the SKU that you purchase. It's either 7 days or 31 days built right into the service. It also monitors your queries for you to see what your poorest performing queries are and can alert you to that and gives you reporting on that out of the box. And also gives you index recommendations that you can then apply with, again, point and click type scenario. So less maintenance time is something we gain from PaaS. It can be a higher service cost, so they do charge a bit more for this, but again, you have to take into account that total cost of ownership. And then finally, a con is that there's possible feature differences. So there, within the database layer itself, there are some feature differences, and definitely at the instance level, there are definitely feature losses, differences compared to on-prem. The two biggest ones that come up that are the most painful in most environments that I've seen would be that you don't get a SQL Server agent with Azure SQL DB, and that you can't do cross-database querying, at least not very easily with Azure SQL database. So whenever I'm considering whether or not you should be running IaaS or PaaS, the question really comes down to what is your required level of control? So do we need to have that access to the Windows server? And what I tried to show here in the diagram on the right there is I look at SQL Server installations as a hierarchy, a three-level hierarchy. So we have the Windows server, that's one layer of the SQL Server. We have a SQL instance where we can run multiple SQL instances on a server. That's another layer, and then we have the database layer, where we have database users, the tables, and all the objects within the database, obviously. The way our Azure platforms line up is shown in that diagram, where an Azure SQL VM would be in the Windows Server layer. And this is where I was going to talk a little bit about the SQL Managed Instance that's coming. That will actually give you a full SQL instance that you can control. It should be, by GA, the way the literature says, it should be near 100% feature parity to SQL instance on-prem. You will get the SQL agent. You can do cross-database queries. You basically get an instance of SQL Server without having to maintain the Windows Server to run databases within. So if we don't need access to the OS layer, but we do need that access and control of the SQL instance itself, SQL Managed Instance is probably a good fit for you. And I know a lot of people are really excited about that offering coming out and looking forward to that coming out. Now, if we don't need that level, even if we're able to stick within our container of a database and that's the level of control we need, we're able to use some other mechanism, for instance, to schedule jobs outside of SQL Agent, then Azure SQL DB or Azure SQL Data Warehouse would fit within that container. And so hopefully we could get down to that level within our platform. So all of that boils down again to my recommendation number one. So my recommendation is that we will choose Paas over IaaS whenever possible. So to take advantage of those lower maintenance times, kind of trying to simplify the amount of maintenance and just data chores that we have to do on our databases, we want to choose Paas whenever we can. Now, a lot of times we're running into things that prevent us from doing that right now, but if we can do it, that's what we want to go with. It also helps us take advantage of new features. So Microsoft is rolling new features out typically to these platform services before they are rolling them out to the standard SQL installation on a VM or on-prem. It helps increase your development agility. So again, being able to tear down and stand up SQL databases very fast. You can script everything out even and do like an infrastructure as a software type setup. And then finally, this is just really the trend of where the industry is going. So be it platform as a service or Docker images, the industry is trying to cut down on the amount of maintenance and just overhead we have in IT and the mundane task we have of doing things like patching OSs every month. Some of the challenges to that, we've talked about them a little bit, but why wouldn't we just do everything in Paas offerings? It's because there's some challenges to do that. So some of those are that we might have to rewrite code to be able to migrate to Paas. This is probably the number one reason I'm seeing if you're doing a migration of some sort up to the cloud, this is usually what's preventing you from going to something like Azure SQL DB. We already mentioned the no SQL agent, no easy cross-database queries, things like that. So it might just take some time to be able to rewrite the application to do that. The size of the database may pose some challenges. So I think a lot of us may have run into that database where someone is just storing tons of image files within the tables within the database. So even though it's an application database, quote unquote, it's 5 terabytes, something like that. And we as good DBAs have done our due diligence to make sure it runs efficiently, but that's not going to fit well in an Azure SQL DB. It's not going to be very cost effective either to do that. So that could be something, again, that could pose a challenge to you. Just weird scenarios like that where the application design was outside of the DBA's control and there's just some strange sizes, one really large table and a lot of small tables, things like that. And again, a lot of times those can be solved with app and code changes, but obviously that takes time and money. And then finally, another challenge is just that it's going to create some process changes for IT and for the DBAs among us. So it's going to require some training on these new methodologies. If you've been a DBA for 15, 20 years and you're used to doing things, your things the way you're used to doing them, like we're used to running OAuths, maintenance scripts and SQL backup scripts, and everything's running and working, it can be difficult to want to try and change those processes, and it's going to require training on how we need to do those things in Azure. So again, that takes time. And then finally, we have to put in some governance and talk about, as IT groups, how do we manage now Azure subscriptions and resource groups? So historically, you bought a server. There was a cost to that server, obviously, but it was a one-time cost, and then we can give developers or people access to that server for development environments, for instance. And you don't have to worry about them necessarily, you know, having that server suddenly cost twice as much as it did the month before. With Azure, it's something we do have to look out for. How do we monitor that, make sure people aren't running away with Azure spend? What are some of the rules and access controls we can put in place to take advantage of the fact that we can spin up and shut down servers, but not give people too much control over that. So I mentioned I was going to sprinkle in some demos throughout. I'm going to demo now Azure SQL VM, just so you can see what that looks like, what it looks like within the Azure portal. I know I saw some people have not really done much with SQL in Azure yet, so this will be a chance for you to see the portal. If you haven't seen this yet, I'm going to go fast, like I said. We do have some webinars on the intro to Azure, and I think we just had one on intro to Azure SQL Database, where the demo will go through this a little bit slower. But I'm in right now, I'm logged into portal.azure.com. I'm in my blades within the Azure portal, and I am just on some virtual machines. I just have 3 spun up within my subscription here. One of these is a SQL demo DB. So this is an Azure SQL VM. Whenever I created this VM, I actually chose a SQL image, so it installed SQL for me. So even though I'm not getting full advantage of my platform as a service, Microsoft has built in some handy things even within the VMs here that still cut down on our maintenance time compared to on-prem. So whenever I spun this VM up, it was already had SQL installed on it. Part of the questions is actually, do you want to install machine learning services as part of that? So it could install that for you automatically. One of the things I want to show you is two maintenance tasks we have on this VM over here on the left. So in this blade on the left, these are all the options I have for this SQL VM. The first I want to show you is networking. So if you're new to Azure, you're new to VMs within Azure, obviously security is a big concern with Azure. Really, this is more of an infrastructure topic. Probably you're going to have an infrastructure or network team that deals with a lot of this, but it's good for all of us to know. On this network, we have network interfaces. So basically, virtually, so it's software networking. But if we want to conceptualize it, this server is virtually plugged into a VNet, into a switch, and these are the network interface rules for this virtual machine. So I even have 2 little orange caution signs here because I did some things that aren't recommended. This is a dev test environment, but I have punched through RDP and SQL from any IP address through to this VM. So by default, it's locked down, so we cannot get to this VM externally. I punched this through so I can remote desktop into it if I'd like to. For instance, if I go look over here, you can see I am on my machine here, and I'm remoted into that VM right now directly. I'm not within a VNet or a VPN. Sorry, I'm not within a VPN right now. That's the reason that's able to happen, is because I have that port open there. Now, the best scenario for this would be to actually set up a VPN between your network and Azure. Again, something we do on the networking side, and then you wouldn't have to open it up from any source. You would just open it up from within your internal VNets. But all this is controlled from the network interfaces. I just wanted to show where the security is controlled on the VM here. Another thing we have control of with VMs with SQL is disks. So Microsoft came out with something within Azure last year called managed disks for VMs. So they actually cut down on the maintenance that we have to manage the disks within Azure. It's pretty simple. I have 2 disks associated to this VM. If I want to add another one, I just have to create another managed disk. I'll just do this real quick. Put it in that resource group. We have a choice between either just HDD or premium solid state disks. So I could pick either. Obviously, solid state disks are going to cost more. We're going to get a lot more performance out of those, though. performance out of those though. And then I can pick my size. I'm just going to do a real small one and then just do create. This should only take a moment here. And what this is doing is it's going out and creating a virtual disk. It's putting it in blob storage behind the scenes. That's the component they took away that we don't have to worry about ourselves anymore. It's going to create a 10 gigabyte disk, associate it to my Windows box. And now I can go into the OS, which I'll skip for sake of time today. But that disk will be presented within Disk Manager within this VM now. So now if I choose this test disk and hit save, now I'll have 2 disks within Disk Manager within that VM that I can utilize. One important thing with this is we talked about the size and kind of larger databases with Platform as a Service. One thing to keep in mind with disks with SQL VMs is that we can scale these pretty large for VMs. You can scale them large for compute, and we can also scale them fairly large for data as well. And one of the things we can do is create multiple disks here. If we're running into performance, we're not getting the disk ops that we need out of the base solid state drives that are available to us. We could do some things like present 4 drives to the Windows VM and then do a RAID 0 or something like that on them within the VM itself to stripe the data across those disks. And again, it's completely redundant behind the scenes, so a little bit of a different scenario than on-prem where you would never use RAID 0 really, but those are some things to look into as well. And then finally, the last thing I want to show you is you'll notice here in the blade, there's a option for SQL Server configuration. So this is actually here because I chose a SQL image whenever I created this VM. It can also be added by installing, there's a SQL IaaS extension for VMs. And what this does is it actually adds a service on the VM that talks back to Azure and gives us some extra capabilities here within the Azure blade. So you can see it's telling me how much space I'm using. It's telling me when my automated patching is scheduled, so we can schedule automated patching on the SQL instance through Azure with this extension, and we can do some automatic backups. So we can create a recovery vault within Azure and have this default to automatically back up databases. I'm sorry, not a recovery vault, this is a backup to blob. We can set this up to automatically back up to blob for any database that gets added to this instance. We can do this within Azure. So again, even though we're not quite getting to full platform as a service capabilities, they are adding and giving us some nice stuff here on Azure IaaS. All right, we're gonna move right along and jump into the Paas stuff. So our second question we had was, what type of data workload do we have? So we talked about we're going to go with platform as a service if we can. So let's say we're in the scenario where we can go with a platform as a service. Which of those do we choose? So we've determined at this point that we're moving down below a managed instance. We're going with some type of DB. So we have Azure SQL DB and we have Azure SQL Data Warehouse. They're only off by 1 letter, just B or W, but they're very, very different behind the scenes. So Azure SQL DB is actually very similar to what we're used to on-prem. So it's a symmetric multiprocessing unit. It's a fancy way of saying it's running within a server. So it's a multiprocessor server with a common bus. The way queries are broken up across that and parallelized across those processors is all handled within a single OS and with shared resources. So those multiple processors share the same memory. The OS and the SQL engine determine how that work gets split up across that one single server. Azure SQL Data Warehouse is actually it's a big data workload platform. So it is an MPP architecture, which means massively parallel processing. And what it does is it actually splits the work across multiple processors, but each has its own OS and memory. So we're actually breaking this up across different servers. So it'll take a query There will be a control node that breaks it up and splits it up across different control nodes. So one query could be divided up across n number of servers. Each of those will take their chunk, figure out what the results are of it, and then pass it back up to the control node. So with that consideration, which of these two should we use? And it depends on your workload here. So Azure SQL DB is really built for OLTP workloads. It's a fancy word for application workloads. It's best for small queries. If we compare that with the Azure SQL Data Warehouse, it's built really well for analytic workloads and for large queries. I put those in quotes because obviously we're oversimplifying things here. Azure SQL DB is not only going to be for just web databases where we just run tiny little queries. There is a place for it to run some report workloads that just aren't going up to like 2 terabyte type databases, sizes like that. So smaller queries on the SQL DB, larger queries on the SQL DW. Another thing to keep in mind with these two is concurrency. So Azure SQL DB is fairly similar to what we would expect on-prem. I forget the total count on concurrent users, but you get a high amount of concurrent users, 3,000 or something along those lines. Azure SQL DW is actually built for few concurrent users. So because of all that work it does to handle large queries and large workloads, you only get 32 concurrent queries at a time. Now it'll queue users and queue their requests and put them into a queue and run them whenever resources become available. But again, it's built for answering large questions. And then size comes into play here. So Azure SQL DB, small to large data sets. SQL DB scales up to 1 terabyte. You could be a little bit lower than that depending on which SKU you roll up to. If you're in some of the smaller premium tiers even, it could be 250 or 500 gigabytes. And then the very top SKU, which is very expensive with SQL DB, goes up to 4 terabytes. On the Azure SQL DW side, it's built for large to very large data sets. So I would actually never run a small data set on Azure SQL DW, even if it was just for a few users and just to run a large query. The reason for that is because of the way it's splitting the data up behind the scenes, you're actually going to cause more work to query that small amount of data than it's worth, and it'll actually slow down your queries. We've seen some customers run into that. So just to explain that SQL DW, I think most people are probably familiar and comfortable with DB and the architecture behind it, but Azure SQL DW, this is an illustration of how that distributed query architecture looks. So it's, again, similar to other big data platforms. We have a control node, so Hadoop or anything like that. We have a control node, and it's going to take the requests, the queries, split them up over different compute nodes. Each of those compute nodes behind the scenes is actually running its own instance of SQL, and it's actually connected to distributions of data. So the data is distributed across Azure storage. You don't really have access to that or control over that, but it splits your data up over 60 distributions. So if you think about that, any table you have would be split up into 60 different pieces. That's where the recommendation of you kind of have to have a good amount of size to your data for this to make sense, because if you break up a 60 gigabyte database over 60 distributions, you're putting 1 gig per distribution. It's going to take a lot of work to do that and then bring it together when you could easily fit that into an Azure SQL DB. The compute nodes are actually controlled by what scale, what size of DW you choose. So if you choose a DWU 100, you would get 1 compute node. If you choose a DWU 400, you get 4, and it scales from there linearly. So recommendation number 2 would be to choose Azure SQL DW if it fits your data. So it is a great offering. It has many advantages over SQL DB, but only if it's the right fit. So it's great for large, well-modeled data workloads, not the correct data platform for all data warehouses though. So just because we have a data warehouse and this product is called data warehouse doesn't mean that we want to put it in there. I definitely work with some data warehouses that are 50, 100 gigs. I would not put those in Azure SQL Data Warehouse. The other thing to keep in mind is going to require some new development patterns to take advantage of the MPP architecture. So we have things like Polybase to deal with and take advantage of really. We're going to need to decide how we want to distribute our data. So we're going to have to pick distribution keys and things like that. And then another thing to pay attention to is there are feature differences with Azure SQL DB versus Azure SQL Data Warehouse. One of the larger ones would be backup policies. So we cannot do point-in-time recovery from Azure SQL Data Warehouse. So that's one thing to keep in mind. So a few more of those feature comparisons, if you're still trying to struggle to decide which of these two to go with. So maybe we're in that kind of gray zone where we're at 750 gigs and they're growing. Which one do we go with? Maybe some of these different features could point you in one direction or the other. So Azure SQL DB, a few options we get with that would be active geo-replication. So one of the things I'm hoping to show in the demo, if we have time, it's a few clicks to create a geo-replicated copy of our database in another region. We have that same feature with Azure SQL Data Warehouse. It'll actually geo-replicate automatically our data to another storage account in another region, but we have to spin up a restore data warehouse from that backup copy. We have built-in point-in-time recovery from SQL DB. Hopefully I'll have time to show you that as well. Don't have that with DW. We can query external SQL database tables. So one way we can get around cross-database queries with SQL DB is we can actually create an external quote-unquote table to another SQL DB and be able to query that from within a second SQL DB. I can't do that with SQL DW, but what we do get is Polybase, which is a way to create external tables to HDFS compliant storage solutions. So blob storage, for instance, within Azure. We can do Polybase from that, and that's really cool. Basically, to sum it up, you can have a set of CSV files or one large CSV file. You can create an external table over that file within SQL. You can run T-SQL queries against that CSV file. SQL DB and DW have one. This is a pretty key difference too. SQL DB you cannot pause, so we can scale it up and down, but we cannot completely shut down the compute on SQL DB. That's one advantage we do have on SQL DW, which is good because it's a lot more expensive. There's obviously beefier servers behind it to run those large queries, and we can pause the compute completely on DW. We'll still be paying for storage when we do that, but we can stop the SQL instance. And then finally, SQL DB, it's closer to SQL parity to on-prem. Most features are there. There's some T-SQL differences with Azure SQL DW, things around functions. We have to maintain statistics ourselves, things like that. So recommendation number 3, this is going to be to use Azure SQL DB if you can. So we kind of eliminated IaaS, we've eliminated SQL DW. Really our preferred option, if those are not, after going through all the other questions we've gone through, is Azure SQL DB. So use it whenever Azure SQL DW doesn't make sense. So Azure SQL DB is great for new applications. New app dev development, I would be definitely looking to see if we can use Azure SQL DB for any new application development I'm doing. That way we get built-in backups, we get the index tuning advisor, easy replication. If you're doing anything new with multi-tenant, so we're developing a new app that requires multi-tenant capabilities, Microsoft has provided some built-in multi-tenant capabilities. We can do things like set up an elastic database pool, which is really a way to just group a bunch of SQL databases, Azure SQL databases together and have them share the costs. So if one Azure SQL DB is kind of expensive on Tuesday, but scales down on Wednesday, and another one ramps up and hits us a little harder, elastic database pools are a way to kind of offset those costs. So we don't have to keep all my databases up at a high level to be ready for those spikes. And then there's also some like built-in sharding capabilities, something to look into if that's a need of yours. And then finally, the way I like to sum it up is it enables us to use our data less, or I'm sorry, manage our data less and use it more, quote unquote, use it more. So instead of having to manage it, index maintenance, database maintenance, all these things, what are ways we can use our data more? It should hopefully free up time for you to dig into the data. How can we use it? How can we leverage our data to make it more of a something that can help us make money as a business versus something that's costing us money to maintain? So I'm going to jump and show some demos on the SQL DB and SQL DW portion. I want to start with actually first showing you what these look like. And I do not have zoom in on this box. I apologize for that. It's a VM. in Azure. But this top server I have them connected to right here is actually the VM that we were just looking at. So this is an Azure SQL VM. You can see I can connect to it from Management Studio. It looks just like connecting to another SQL instance on-prem. So everything's here. I have my databases, replication. I can set up always-on availability groups with VMs. In fact, it's recommended so that you can take advantage of the high availability within Azure itself. Connect to this like normal. One thing I want to show you with Azure SQL DB and Data Warehouse is you'll notice I do have a server I connect to, and then I have the databases within. So I have an Azure SQL Data Warehouse called Demo DW and a DB called Demo DB. And they are actually in the server called Gall SQL 01. This server is just a logical server. So with the Azure SQL DB and DW platforms, we do have a quote-unquote server. It's really just a container to hold our databases. And with it, we get a login that is our master login. So we do get a login that has access to the databases on this instance. And that's pretty much it. So we don't have the agent, we don't have linked servers, we don't have any of that available to us. It's really more of a logical server. So something to keep in mind. And you can mix DB and DW into a logical server. Besides that, when I connect to the database, I can open up tables, I can run queries here. So again, just like I could an on-prem database, everything should look pretty similar within the databases for an Azure SQL DB or Azure SQL Data Warehouse. So I'm going to jump back over to the Azure portal. And we're going to go look at our Azure SQL Data Warehouse first. And so one thing you'll notice up here at the top, so pretty much every resource within Azure starts with this overview tab. So I have the resource here on the left, then in the next blade I have my options. In this overview tab, they usually put the most common features as a button up at the top. So one thing I could do is restore this database. We'll see this here over on Azure SQL DB in a moment. In the start button, I'm just going to go ahead and click it. Right now that database was paused. So if I tried to connect to it over in here and run a query, it should give me an error saying, cannot connect to the database because it's paused. So that database is offline right now. I had paused it and I was not accruing compute costs on it. When I switch back over here, I had clicked that start button. You'll notice my little alert button is starting to resume database in progress. It's spinning that database back up so I can start running queries against it again. So it's a really good fit for Azure SQL Data Warehouse, especially if you think about a lot of times we're doing batch processing with our data warehouses. So a pattern to think about, and we're not going to go deep into this, but a pattern to think about could be to use this primarily as a batch processing system where we fire up our data warehouse, do our ETL loads, run whatever ETL code we need to within that, process maybe an analysis services cube off that data, and then pause the instance and shut it down. So we're not accumulating costs on it all day long, and then during the day our users can do reporting against our analysis services instance. It's a pattern you can think about and take advantage of that pause with compute there. Now let's take a look at our demo DB. So this would be an Azure SQL DB. Another thing I wanted to point out before I jump over too quickly is you'll see this is the list of options I have within Azure for Azure SQL DW, Azure SQL DB, a lot more options. So some of the feature differences I pointed out that you should look into, you can see just by looking at the Azure portal, there's a lot of options for Azure SQL DB. One of the things I want to show here, we have the restore, again, our common commands up here at the top within overview. One thing I want to show is restore. So I'm going to click on restore. I was on the database itself, I clicked restore. It's picking a name for me. What this is saying is, hey, what point in time do I want to restore this database from? So I could pick whatever time I would like, as long as the database existed at that point. So I could say 3 p.m. On Monday. I need to get a restore from that point because we think we dropped an object around 3:30 that day. It says, hey, what server do you want to put it on? Do you want to put this into Elastic Database Pool? And what pricing tier would you like to choose for this? So that's the pricing tier I'm on by default. It picks that. If I just click OK on this, it's going to kick off a restore and restore that database to the point in time at 3 p.m. yesterday. And we'll see it on here in a moment. If it completes in time before the webinar is over, it'll show up within SQL Management Studio, and we'll be able to go pull whatever object out of there we needed to. So really quick point and click recovery for point in time, which is a really nice feature. Two more things I wanted to show here for Azure SQL DB would be geo-replication. This is just one of my favorite features just because of how easy it is compared to having set up availability groups or set up transactional replication within a database, things like that. If I want to replicate this database, so right now this map is showing me, I have this in the East region within Azure. All these little green boxes are all the different Azure regions that Microsoft has right now. The purple is where Microsoft has chosen as target regions for replicating this for DR purposes. It's far enough away from the East to hopefully not be affected by any natural events. So I can just pick a target region, West 2. My database name there is kind of grayed out, but it's the same name that I have right now. I can pick which type, make this readable secondary. I don't have a server right now, so this is that logical server. That logical server I talked about before. I'm going to give it a name, password. It's going to West US 2. I'm just going to say select. So it's going to create that logical server for me now. And I'm just going to say OK on that. And again, hopefully I'm not doing too much with the restore at the same time, but it's, you can see it's showing me in the GUI there that it is replicating that database right now out to the West Coast and creating a read-only secondary there. This would be not just a copy of the database, but it's a replicated copy, meaning if I start adding data within the East region, it's going to replicate that data out to the West region. So this serves us for disaster recovery purposes. So if anything happens within the Azure, and the really unlikely event actually that anything happens to that whole Azure region, we have a backup of it out on the West Coast. But also if I have West Coast users, I could use that as a read-only secondary to do some reporting off of that instance out there as well. And that should run and complete here in a few moments. We won't wait on that, but that's all it took to set up replication for that. And the last feature I wanted to show would be under performance. So one of the built-in things I've mentioned a few times is that we get performance recommendations built in within the Azure portal. So this is showing me, this is a very small demo DB in Adventure Works, and I haven't been doing much on it, so we don't have a whole lot of recommendations, but if this was an active database, you'd be seeing a lot of stuff here. You'd see the top 5 queries. If we go to performance recommendations, this is where it will show me what indexes it recommends to add. It'll actually show you indexes that it recommends to remove as well, especially if it finds duplicates or just indexes that aren't being used at all and it doesn't foresee being used. What it does when it shows you those, there's a way to automate it. So if there might be some scenarios where we would trust Azure to go ahead and remove or add those indexes. More often than not, you're going to want to take a look at them yourselves, but then there's just a button you can click and it'll apply that index or remove that index for you. And then finally, under Query Performance Insights, again, we can click on what are not just our top 5 queries, but what were some of the longer running queries we've had recently. And if you click on those, it'll show you what the query was and what syntax we had there, all built in. So for sake of time, I'm not going to dig into those too much, but just wanted to, again, kind of give you a feel for the different platforms in Azure and show them to you. And with that, I just have one more slide, and then I'm going to open it up to questions. So final recommendations on this would be look into all of these different options, kind of ramp up on what you can do with each of them. We gave some tips on how to choose the different options, but more than likely, you're going to do a combination of all of them, especially those users that mention that they support both application and reporting type databases. You're probably going to combine these all in some way, shape, or form. So most environments will have a mix of different options. If you're thinking about Azure, if you're not thinking about Azure, I would still start looking into Azure now. If I was an IT professional, not in consulting even, Azure is coming, and we should all be looking into how we can take advantage of it and keep our skills up on how it's going to affect our jobs. And then finally, just another thing to point out that we're seeing as a consulting firm for migrations to Azure is a common migration pattern we're seeing as servers become stale and need upgrades, or data centers are starting to kind of come up on their contracts in their colos, things like that. But maybe you don't necessarily have the time to do a migration and upgrade your applications. We see a lot of lift and shift scenarios where we're lifting and shifting SQL instances to VMs, and then picking off databases and applications one at a time to migrate them over to platform solutions. So that's a common pattern. Keep in mind, just because you migrate to Azure SQL VM doesn't mean you're stuck there. It could be a good first step into Azure. Get your feet wet there, get off of your old aging hardware, and then look into how you can re-platform your applications. So that's what I had for today. I can open up to questions now. Liz, I'm not sure if you had any questions or if, ready, or if you'd like me to kind of look through the list. I'm open either way.
I've got them.
Perfect.
All right. Was agent available with Paas or IaaS?
So the question is the agent available with Paas or IaaS? SQL agent is only available within a managed instance. So if the Paas offering that is a SQL managed instance, it will be there when that becomes generally available. Otherwise, it's only available with IaaS.
Does Azure SQL Database offer NUMA, or is the only option SMP?
Azure SQL Database is, I'm not sure if it's NUMA node in the background. Really, that's one of the nice things. You don't have to worry about the NUMA nodes. We're not worrying about the hardware architecture behind the scenes, but it is SMP compared to MPP platform comparative. So Azure SQL DB is SMP and Azure SQL Data Warehouse is a MPP.
Okay. We have an on-prem SQL Data Warehouse. We are also using Azure ML VMs for analytics. Is it possible to host a passive copy of our on-prem data warehouse in Azure, updated nightly, so that we can pull data from Azure Data Warehouse, copy into our ML VMs? How would such a solution look?
So the answer in short is yes, you can definitely replicate the data up there. The answer and how that would look is a little more complicated. You have a few options there. So a few options to look into, and that we could talk to customers about too, is you could set up you can replicate to an Azure VM. The other option is there's something called data sync with Azure SQL DB that will work on-prem. So you can sync on-prem SQL databases into Azure SQL DB via something called Azure DB Sync. It's not I have not seen it used commonly, but it is definitely an option. I've probably seen transactional replication used more often, or some type of nightly ETL load. That would be another way to do it.
Can we use Windows Auth with Azure SQL Database or Azure SQL Data Warehouse?
Yes, you can use Windows Authentication. They both now support Azure Active Directory. So if you sync your on-prem Active Directory to Azure Active Directory, so there's an AD sync component that allows that to happen, we can authenticate with Azure Active Directory to both of those platforms.
Okay. We are currently using Violin memory storage with microsecond latencies for all three components running on it: relational DB, SSIS, and SSAS multidimensional cube. How to migrate such an environment so it will work in the Azure environment with its slow storage system?
So you're probably on definitely a complex scenario with that setup. The way to speed up the storage systems within Azure would be to do something like I mentioned, where you RAID together multiple virtual disks on the VM. See if that can get the performance you need. Otherwise, there are still scenarios right now where in that hierarchy I showed on the one slide, where you just need the bare metal, raw, fast power and stick on-prem with that. It's becoming fewer and fewer where you just can't go to Azure. It can be kind of expensive, so you definitely have to look at the cost and making sure that you can squeak out all the performance on those VMs and that storage you can in Azure.
How about SSIS and Paas, storage and execution of what were SQL agent jobs?
So the way we get around executing things outside of SQL agent jobs would be Azure Automation account. So we can create an Azure Automation account, which is really a way to run PowerShell scripts. So we can just run PowerShell scripts, keep them simple, and kick off SQL tasks that way. With SSIS, look into Azure Data Factory version 2. I think it might be the webinar next week, actually, is Azure Data Factory version 2. That adds support for SSIS. So we now have a platform as a service SSIS offering. It's built into ADF v2, and there's a scheduling component built into ADF to kick those off.
Does creating a logical server with data warehouse and database help in data movement? Any faster, more optimized?
It's a good question. Not to my knowledge, no. It's purely a logical server. The databases still are not really linked together in any way. I've never asked a Microsoft engineer if it somehow or another keeps them closer on the rack or anything like that, but for all intents and purposes, I would not count on getting any performance gain out of that at all. Just because they're on that same logical server, they cannot crosstalk each other. We cannot run a cross-database query on them.
Can you restore from an earlier POT in Azure SQL database into another database?
Yes, so actually that demo I showed, it was restoring it into a new database. Let me see if it completed. Maybe. The answer is yes. Let's see if I can refresh. We should see a second database here now. Yep, so it restored it into a second database with a timestamp for the time I picked at the end of it. So the restore puts it into a new database by default.
What is the most cost-effective Azure data storage for applications?
The most cost-effective, so the cheapest way to store data in Azure is Azure Blob Storage. Pretty straightforward with that. And from there, you get more features storing it in other places. If you're just talking about application, you could look into Cosmos DB. That's going to be more expensive, but it's simpler to develop around because it's schemaless. If you're looking at purely cost, blob storage is the cheapest.
Do you know the status and/or plan for full-text iFilter support for documents and PDFs in Azure SQL Database or SQL Managed Instance?
I do not know that one off the top of my head. I'd probably have to follow up on that one.
Okay. Does SQL VM require a SQL license?
So VMs on SQL and Azure, they do require a SQL license. There are a couple ways you can do that. So you can actually save money on the Azure cost if you're in an EA agreement and you already have your Azure SQL licensing. There's a way you create the VM to say you're bringing your own license. The other way though is it is required, but it's built into the cost. So if you just pick a template from the Azure VM catalog and it has SQL on it, the license comes with the server then, so you do have to have it, but it's built into it, so you don't have to worry about it. And actually the licensing cost is built into the per hour cost.
We do have several more questions, but we're running out of time, so I'm just going to pick a couple, and then Brad, I'll see if we can send them to you and get these up maybe on a future blog.
Sounds good.
What is the alternative to SSIS if you want Paas SQL DB?
So the alternative to analysis services would be Azure Analysis Services. So there is a Paas version of analysis services called Azure Analysis Services, very similar to what we saw here for SQL DB comparative. Actually, though, there's a lot more feature parity between on-prem and Azure for analysis services.
How do you compare the performance of on-prem SQL Server with SQL Azure Database?
So that's a big, there's a lot of it depends there. So I didn't get into scaling the DBs here, it's something we talk about in a lot of other webinars, but you can scale up and down the database. It's not just a one level of performance. So it depends on what level you choose there. Um, they go up really high. They're really expensive. I forget what the most expensive is off the top of my head. You're in the over $5,000 a month for a database. You get a lot of performance out of that. So it kind of depends on what level you choose. Then comparatively to on-prem, it really depends on what type of hardware, what type of SAN you have there too. So something to kind of baseline in both environments and figure out what you need.
One more question. Can Data Factory be a workaround without having agent using Paas?
Data Factory could be, yes. Now with Data Factory version 2, there's a lot more GUI. It's in preview though still, so version 2 is still in preview. I haven't implemented that in any environments. That is a good thought. It's a potential to schedule kind of orchestration there.
Okay. So we are out of time, everybody. I know there are several questions that we did not get to. I'll make sure to send those to Brad, and we will get him to do a follow-up blog. So if you're not already subscribed to our blog, just head over to blog.pragmaticworks.com and subscribe, and you'll be notified when anything gets posted. We also have a lot more content on Azure. We have a series called Azure Every Day, where Brad and several of the other guys on the team are creating content, and we're posting new Azure content every weekday. So I really encourage you guys to go check that out. But a lot of your questions could probably be answered over there. If you do have questions that you didn't get to put in the window and you would like us to answer, please email Brad directly. It's bgall@pragmaticworks.com, or you can follow up using the email with your GoToWebinar information, and we'll be happy to get that to the right person. As always, this session was recorded, and you'll receive an email tomorrow with the link. Thank you, everybody, for joining us. Thank you, Brad, for presenting, and we'll see you all in the next session.
Thanks, everyone.